Hi, so let's talk about Python classes today. So when you first start learning Python, you often start by learning to write simple functions, and then they become bigger and bigger. But at some point, you're going to need classes, and it can be a little confusing. So this transition from functions to classes in terms of your learning, this is what we're going to talk about, right? So we'll take an example of doing something simple, relatively simple, in a functional way, and then we'll see what are the advantages of turning it into a class. And of course, we'll talk about the pesky self keyword when you're dealing with classes, right? So I have a data dictionary kind of an item here. This could be an item in your inventory, on your online store, or whatever it is. It's a standard Python data dictionary, so no classes so far. It is defined, it has an ID, a name, a price, and a quantity. It has these 4 parameters in it. And if I just print it out, it prints out quite nicely. Item. And it shows me all 4 things. Suppose I want to simulate a sale on this thing, right? So one of the things that I will want to do is to reduce the quantity after the sale is done. So I will just go item, and then we'll look at the quantity like so. Okay. And we'll reduce this by 1. And if I print it out again at this point, you will find that the quantity is now lower, right? Quantity, sorry, thought I misspelled that. Right, so the quantity is now lower, and now instead of 9, you have 10, you have 9. Now one of the problems with this, of course, is that if you have a very large quantity here, it'll still happily do that and reduce the quantity to minus 90. So you start writing this code like this, and you say, this is not right. And immediately, if you are used to functions, you'll say, all right, I'll write a sales function, and it'll check the quantity before reducing it. And you might end up writing something like this. So let's bring this upstairs as well, and put it over here. And it's a fairly standard kind of a simple function. It is called sale. It takes an item as a parameter. Then it has an amount, the amount of the sale. And if there's enough of the quantity, then the sale is made. Otherwise, we say, we don't have enough. And now, instead of item quantity being reduced, we are just going to go sale, and we'll pass it the item parameter, and we'll pass it, let's say, 9 to begin with, and then we'll see if the sale is made. And if I run it like this, it is still the same. The quantity goes from 10 to 1. But now, if I would try to sell 90 of these, it'll warn me, and it'll say I don't have enough, and it will not work. Now, you could then have some kind of a restock function, and then you will define a restock function here, and then so you will have a bunch of functions around your data type of item, and then you will just have them all over your file. Now this is where you start thinking about classes, because with the class, the data for the class and the functions, things that you can do with the data will all get encapsulated in one structure called a class, and it has some other advantages as well, as we will see in a minute. So let's define a class now. A class starts with a class keyword like so. It is given a name. I'm going to call it item with a capital I this time, with a colon. And then I'm going to define some functions within the class. And the first function is going to be called a special name, underscore underscore init underscore underscore. Now this is a special function. This function gets called as soon as a class instance is created. And in a minute, I'll show you what exactly this means. But for now, this instance requires certain parameters. And the parameters that I'm going to pass to it are self, and we'll talk about self in a second. But then the properties that we had in the item, ID, name, this can be anything you like, of course, but in our case, we require these for our data structure, quantity and price. And inside of this function, what we're going to do is we will assign the properties that are getting passed in to instances of self. So self ID is going to be equal to ID, self dot name is going to be equal to name, self dot quantity is going to be equal to quantity, and self dot price is going to be equal to price. And there it is. We've just created our first class. Now we have a class. What can we do with it? Well, we can now define a variable of this type class, and let's just do that right now. So x, I will call it equal to capital item. And as soon as I do that, you notice I get the IntelliSense, and the 4 parameters that are defined over here are expected in when we define any instance of that type item. And so let's just do that. ID is 1, name we'll call it widgets, and quantity can be whatever we want, 100. Price, let's just say, is equal to price is equal to 100. So now we have an instance, and if I print it out like this and I look at it, notice that it is called an instance at a certain memory location, right? So let's now step back and understand exactly what's going on. First of all, we define the class like I mentioned before. It has the class keyword. It has a function within it called init underscore underscore init, which is called automatically. And when we actually define a variable of this type and we print it out, we get an instance of this class. Now, the reason it's called an instance is because when the class itself is defined, the class is basically a blueprint. It is a pattern that tells Python, look, if something of the type item comes along, then this is how you're going to construct it. But it does not actually set aside any memory and actually define in which the actual values of x or y of any variable of its type are actually stored. That comes later when we actually define a variable of this particular class. And that is why the variable is called an instance of this class. And that is what Python is telling us, that x is an instance at this particular memory location. In fact, if I now define another variable like this, we'll call it y, and let's call this boxes. And the quantities can be anything, but let's just change them around a little bit just for differentiation. And if I print it y this time, and if I run it like this, now you have an item instance at this particular memory location, and you have another item instance at a different memory location. So first of all, you have it at 20148, and then you have it 201C8, and they are both instances of the type item. And so there can be many instances of a single class, but there is always going to be exactly one class. So that's the difference between a class and an instance of a class. Now, what about this self parameter? Because you notice that while there are 1, 2, 3, 4, 5 parameters here, when we actually create a class, there's only 1, 2, 3, and 4 parameters that are actually passed to the class and therefore passed to the default init function. So what's going on over there? Why don't we have a fifth one here which actually passes the self? Well, it turns out self is a reference to the instance of the class, because the class, when it's called, has to determine where exactly should it do the storage of the items of that particular instance. So every time a function within class is called by one of the instances, the instance passes a reference to itself to the class. And that is always stored in the first parameter within each function in the class. But by convention, Python expects us to declare it explicitly within the class, but does not expect us to pass it explicitly. So you end up in this strange situation in which you have 4 parameters over here and 5 over here. So just remember that the first parameter definition within the class is always going to be self. Now this can be slightly confusing, although you get used to it, but if you're coming from any other language, then this is slightly unusual. Most languages will have the self reference, but they will not require you to declare it within the class in this explicit function. But Python does. Just get used to it, and then it becomes a habit, and you don't even mind it. Also, remember that this self keyword is not, the name doesn't have to be self, right? I mean, I can actually rename this, and let's just do that right now and rename it to even XXX. Notice that when I rename this and rename all of this, they become XXX and so on, and it'll still work, right? So let's just prove it to ourselves. It still works because what really Python expects is for the first parameter to be a reference to the instance. You can call it whatever you like, but by convention, it is called self. And so any Python code that you notice anywhere or you read anywhere is going to have that. And so let's just stick with that convention and call it self. So we have a class now, but let's add some more functionality to it. So for example, if I want to print the name and the price of each item, one way to do it is to just go print x.name and x.price. And for y also, I'll go x.name and y.price. And if I do that and I run it, the names, etc. are printed as expected. But because we have a class now, what we can also do is to define a function within the class to do this for us, and then it'll become easier. Let me just show you. So I define a function here called print details, and within that, I need the parentheses here because it's a function. And within that, I just go print self dot name and self dot price, and I leave it at that. And now instead of doing the print statements like this, I can actually do them by invoking the print detail function on a particular instance, right? So I go print x dot print details and y dot print details. And if I print it like this, you should run this function within the class item, but something interesting is going to happen. Let's just take a look at it. We get an error, and the error is quite an interesting one because it says print details takes no arguments but one is given. So what's going on over here? Now notice that I did not add the self keyword here, and when I invoke the print details function, it's implicitly passed the reference into it, and there's no variable to take that reference, and that is why it's complaining that no arguments, that one argument was given, even though. So this can be very confusing when you first start with classes, because that error says that you're giving one argument, but you look at your code and you say, well, actually I'm not giving any argument. And so what's going on over there? So again, it's the self property that is causing this error. Again, we don't need to explicitly define it here, but even if we don't pass anything, it gets passed implicitly anyways. And so there has to be a variable on this end, which has to be the first variable to take it. So I'll just add the self keyword over here. It's not a keyword, sorry. It's just the variable name over here, which is self by convention. And if I run it now, it will happily print them out. So now I have widgets and boxes. And now because this is contained within the class, I can actually, get more fancy and add more stuff to it. So I say self.price and also self.id and self.quantity, and this will apply to both X and Y simultaneously. So it becomes easier to just change it in one place, and all the objects, all the instances which are using this particular class will automatically update and print properly. In fact, because we now are doing it like this, we can actually get a little bit more fancy, and I have it written down here. So I just copy paste it in because it's a long statement and I don't want to bore you with while I type it out. Let's just paste it here. And so this particular just get the indentation right. This particular print detail function it looks long, but basically what I've done is I've got added strings to it. So there are titles. So this is the ID within the strings. The /n is for the new line, and then it prints the ID because it is being concatenated with a string. So we have to use the str keyword to change the numeric value self.id into a string. And then there is the title name, again starting with the new line, and then the name itself, which is the property within the class, and then the price and so on and so forth. Let's just print it out and see what it looks like, and you will see what I mean. So if I print it out like this, of course I get an error because I call this print details 2. It should actually be print details. So let's just run it again. And now you see we get a nicely formatted printout. So ID is 1, name is widgets, price is price, quantity in stock. This is coming from right here, quantity in stocks. And because I'm printing both, it prints the first one and then the second one. Let's just actually change the ID for Y to differentiate them and run it again. And yeah, so ID 1, ID 2, and so on. And so by having this function right in here within the class, I don't have to touch any of my code outside of the class. And all the invocations, they change automatically. The code is now compact, it is self-contained. Everything to do with the item is in one place. So now let's add some more functionality to our class and do the sale function that we were trying to do, the sale functionality that we were trying to do through functions previously, right? So I just copy paste a function in within the class, of course, and then I'll explain how this works. So again, this is the function that I have already prepared. It is called sale. Again, the first parameter has to be self, as we've discussed before. This is for the reference, but the real parameter is the amount of the sale. And it does the same things that we were doing previously in our functional approach to this thing. It checks the amount. If there is enough, then it will actually deduct it. If not, it'll just say not enough in inventory. It'll also print out a nice message saying how much was the sale made. And if the quantity has now reached 0, it'll do one more thing. If the quantity after the sale, after the subtraction has reached 0, it'll say, this particular item is out of stock. So it'll do all of this for us. It is contained within the class. And because we have it in here, we can now invoke it like this. So let's just work with X for a while. So I'll just get rid of this. So X print details and then X dot sale. And we've sale an amount of, let's say 2 to begin with. And then we print out the details of X again, print details. And if I run it like this, you get this nice little display first. The widgets are 10, and then 2 of them were sold, and then 8 are left, right? So again, functionality is something that we were achieving through functions separately as well, but notice how compact and how neat the code is, right? Everything to do with the item is now contained within the class, and it's very easy to work with it. It's much clearer and it's much cleaner to work like this. And of course, if this was a real life function, then at this point of time, if it's out of stock, you will probably call a stock module somewhere else in your code to sort of restock the item and so on. Also, if I now try to do a sale which is more than the inventory amount, so let's just say try to do a sale of 2000, then I get the other message, which is basically not enough in inventory. So you get 10 to begin with, it says not enough in the inventory, and then it does make the sale and you still have 10 because the sale was not made. So let's just round out our class by adding one final function for restocking. I'll just copy paste that in and then explain it to you. It's a fairly straightforward self-explanatory function. It is called order more. It takes the cell parameter because it's within the class and that is always required. And then it takes a quantity parameter, which is exactly how much to order. And so it prints out a statement telling that it has ordered this particular quantity of this particular named stock item. And then it increases the quantity parameter of that item by the amount. Now, in an actual module, of course, at this point, you will probably call some kind of an ordering module, but we're just simulating it with a print statement. Now, this is a function within the class. So how do we actually call it? But the logical place to call it is when we are out of stock. So you say, well, I'm out of stock, but then you call the functions order more. And so self dot order more, and you give it a quantity of, say, 100. So as soon as you're out of stock, you order 100 more. Now notice that this time I'm calling a function which is already within the class from another function which is within the class, from within the sale function. And so I have to tack on the self dot order more. And so the convention is the same. If you call or refer to any items of a class from within the class, you have to have the self keyword, which is the reference of the instance that was passed in. If I was calling this function from outside, then I would not need to do the self over here, but I would just call it like I'm calling in a regular fashion over here. Like I'm calling this sale function. So let's see what this looks like. Let's just run it at this point. I have X, which has a quantity of 10, and I'm going to make a sale of 10, which will make it out of stock. And let's see how that gets handled. So let's just run it now. And as you can see, first of all, we had 10 items in stock, 10 were sold. It gets the message which it is out of stock, which is coming from within the sale function, right? So it is out of stock right here. And then it calls the order more function. And so it says 100 of the widgets ordered, and then finally it prints out the item again, and now we have 100 in stock because 100 were just ordered. So this is our complete class at this point. We'll stop here, just take a look at the whole class that we have defined, and notice how compact it is, and all the functionality, everything related to an item is in a single place in our code. It is easy to work with, and once you've written the class, the actual code to work with that class is extremely compact and self-contained. And of course, the more complex the class becomes, the more convenient it is to have these items within a class. And that is how classes, and that is why I should say classes get used in the first place. Now there's more to learn about classes. There are class variables, there is inheritance and so on. And perhaps we'll do a separate video, but this is the basics of the class. And I hope you found this useful. Thanks for watching.